Hello everyone. In this video, I will explain the machine learning lab experiment 2, which focuses on features selection techniques as well as feature extraction techniques, also dimensionality detection with image feature extraction. So we are using the Toyota dataset and performing step-by-step feature filtering and transformation. So let's go to the questions. And we are importing pandas, numpy, matplotlib, scale-on feature selection like select tables, chi-square, mutual info regression and pre-processing standard scalar and discriminant analysis like linear discriminant analysis, and you are also importing CV2. So let's get in the question. So first we are reading the data, and we print the original shape to know how many rows and columns exist, and this gives us the starting dimensionality of our data set. And then for the question 2, we are dropping the Bovag guarantee and doors column. So the reason is because these features may not contribute significantly to what we are trying to do, or they may not be required for further analysis. After dropping, we print the new shape to confirm column reduction. And then for the third question, we are identifying and dropping numerical columns with outliers using the IQR method. So we select the numerical columns and then compute IQR for each of these columns, where the formula of IQR is Q3 minus Q1. So outlier condition, the value should be greater than Q3 plus 1.5 into IQR. If a column contains outliers, we add it to a list and drop it. So the purpose of doing this is like columns heavily affected by outliers may distort our model's performance. So we're doing this. And then we are identifying and dropping columns with variance which is less than 10. So we calculate the variance using the formula summation of x minus x bar the whole square divided by n. So the low variance means like the feature does not change much. It carries very little information. So we remove features whose variance is less than 10. So this is called variance thresholding. And then for question number 5, like we are identifying columns with correlation less than 0.2 with price. So we are computing the correlation with target variable price. So correlation we are finding using covariance of x into x comma y divided by sigma x into sigma y. So if absolute correlation is less than 0.2, that feature has very weak relationship with the column price. So we store such values. So then for question 6, we're dropping columns with the correlation less than 0.2. So now we remove those weakly correlated features. Like the purpose to do this is because to keep only features that influence the target variable. This improves model interpretability and reduces noise. Question 7, we are finding highly correlated feature pairs, which is greater than 80%. So we're computing the correlation matrix. If the correlation is greater than 0.8, then two features are strongly correlated. This causes multicollinearity and redundant information. We store these feature pairs excluding price. Then for question 8, we are dropping one feature based on correlation with price. So this is based on highly correlated pairs. For each highly correlated pair, we keep the feature that has higher correlation with price. We drop the weaker one. The reason we are doing this is to remove redundancy and retain the most useful feature. This improves the model stability. And then for question 9, we are separating x and y. So x is the independent feature and where y is the target variable. Here the target variable is price and x is the independent feature. So this is required before features selection techniques like chi-square, MI, PCA and LDA. So like for question 10, we are using select k-bus using chi-square where k is equal to 10. So using the select k-based um, method here. So chi-square measures dependency between feature and target. Higher chi-square value means stronger relationship. So the important thing is like chi-square requires non-negative values. So this is why the absolute values and missing values fittings are done here. We select the top 10 best features. That's why we are giving k which is equal to 10. So next, the 11th question is mutual information. So we compute mutual info regression, the model which we imported from Scala. So how much information a feature gives about the target. So we are getting the information like from the feature about the target. So if mi is equal to 0 means there is no relationship between that. And if higher mi means stronger dependency. We print the feature with highest mi score. So here the highest mi feature, age has the highest mi feature. to the price curve. Then next we are going to the question number 12, which is the PCA, which is principal component analysis. Now we move to the feature extraction part of the experiment. So first we are filling the missing values. We are standardizing data using the z-square formula, which is x minus mean divided by standard deviation. Then we are computing covariance matrix, and then we are computing eigenvalues and eigenvectors. Then sort eigenvalues in descending order. We are selecting top two principal components here. And then PCA transforms original features into new orthogonal components that capture maximum variance and reduce dimensionality. Output shape conforms reduction. And then for the 13th question, we are doing LDA, which is linear discriminant analysis. We apply the linear discriminant analysis model. So difference between PCA and LDA is that PCA maximizes variance, while LDA maximizes class separability. LDA considers the target variable. It protects data in a way that maximizes between class variances, minimizes within class variance. So that's the use of it. And then for the question number 14, we are doing image feature extraction. So we are loading the image using cv2 dot mread the file name. And then first we are converting the BGR to RGB. Then we first display the original image. Then we are computing pixel by pixel mean. So this converts 3D color image into 2D grayscale like matrix. This matrix represents image feature extraction. Then we visualize the mean matrix. The purpose of this is to demonstrate feature extraction from image data. And finally, in this experiment, like we have performed feature extraction and feature selection, and we have used various methods like outlier based filtering, variance filtering, correlation based feature selection, multiple linearity removal, chi-square feature selection, mutual information analysis, PCA dimensionality reduction, LDA supervised feature extraction, and then image feature extraction. Like this, this experiment demonstrates both major parts like feature selection and extraction, which are like crucial steps before we are building a machine learning model. So that's it. Thank you.